अगर अगर तुम रिकॉर्डेड वीडियो देख रहे हो तो मेरे चैनल पे जाके न्यू लाइव स्ट्रीम ज्वाइन कर सकते हो, और चैनल पे नए हो तो सब्सक्राइब कर देना और वीडियो को लाइक कर देना। चलो स्टार्ट करते हैं। 60 वर्सेस 10 का पोमोडोरो ओपन करेंगे। 1 घंटा पढ़ाई और 10 मिनट का ब्रेक। तो एक बार कैमरा चेक कर लेता हूँ, फिर फ़ोन को साइड में रख दूँगा मैं। ठीक ही लग रहा है। थोड़ा सा सीधा करता हूँ, फिर टाइमर स्टार्ट कर देंगे। थोड़ा ठीक है, चलो। फ़ोन को रख दिया साइड में। टाइमर लगाते हैं 1 घंटे का। अभी मैं स्ट्रेंथ ऑफ मटेरियल सब्जेक्ट कर रहा हूँ, तो वो यार बहुत लेंदी है। 150 आवर्स के लेक्चर है उसके। देखते हैं अपन कितनी देर में कंप्लीट कर पाएंगे। 1.5x पे देखता हूँ मैं, शायद 120 घंटे में हो जाए, क्योंकि नोट्स बनाने में थोड़ा टाइम जाता है। स्ट्रेंथ ऑफ मटेरियल स्ट्रेंथ ऑफ मटेरियल SOM हाँ, मिल गया। सेकेंड लेक्चर शुरू है, चलो।
If at 10
1.5x. Let's start.
the exact equation for shear stress. किसी ने पूछ, can you write down shear stress equation लिखो, तो बोलो तो एक इक्वेशन लिखना पड़ता है। Average shear stress, what are the name of mean shear stress? एक एग्जैक्ट इक्वेशन नहीं है। एक इक्वेशन कैसा अपडेट हो गया था when you are इंटीग्रेट करने के टाइम पे। सिमिलरली इक्वेशन कैसा था, सेम हाउ यू आर डन इट, या व्हाट यू आर डन इट। आप इंटीग्रेट करने के टाइम पे सिग्मा को आउटसाइड इंटीग्रेशन लिया था। कब इंटीग्रेशन करने टाइम में कब आउटसाइड लेंगे, कांस्टेंट है तो आउटसाइड इंटीग्रेशन लेंगे। बोले तो इधर प्लस इज कांस्टेंट मींस एट एवरी पॉइंट सेम, so this also you are going to get about the metabolic taken outside the integration, so this is also valid. So once again, both these two terms are representing both.
Internal resisting force, shear force developed on the entire cross section area.
Internal resisting shear force developed on the cross section, and this equation is valid when shear stress uniformly distributed.
Valid when shear stresses are uniformly distributed at every point on the entire cross section.
whether you have studied the strength definition, you have studied or not. So quickly I'm going to write down the strength definition.
एक मिनट
Studied
क्या
or not?
बोला?
In the last class, I'm able to remember whether you have studied the strength definition, you have studied or not. So quickly I'm going to write down the strength definition. There are some technical power issues there, continuously what now? Power fluctuations are here. So quickly I'm going to write down probably I already written the strength definition. Strength is defined as the
स्ट्रेंथ डेफिनेशन जाने तो लिख लेते हैं। मेड इजी के टीचर ना मुंह से एक्सप्लेन ज़्यादा करते हैं और लिखते कम।
is defined as the maximum or limiting value of stress that a material can.
Strength is defined as
The
the
definition I already written in the last class. Material can.
strength, strength, strength,
That
strength, strength,
failure and fracture you have studied now. Without a failure or a fracture.
strength, strength,
So this definition also
strength.
what is the difference between stress and strength? If anybody asks what is the difference between stress and strength? Both are having the same unit. Stress units and stress units are same. Stress units and stress units are same. But what is the difference now? There are two different. What is the first difference now? If anybody asks what is the difference between stress and strength? there are दोनों बीच में दो डिफरेंस है. पहला डिफरेंस डेफिनेशन ही एक्सप्लेन करो. Stress is representing magnitude of internal resisting force developed at a point under given load. Strength is the maximum stress that a material can withstand without a failure or a fracture. And what is the second?
Strength.
Stress is a variable. Stress is a variable. If there is no load, there is no stress. If the load is P1, stress is sigma 1. If the load is P2, stress is sigma 2. As the load increases, resisting force increases. Stress also increases. So stress is a variable parameter, but stress is a property. Stress is a property of a material. So there are two different. Simply, first difference is about now. Give the definition. Second difference is stress is a variable parameter, sir. Stress magnitude depends upon the externally applied load. We are discussing the gradually applied load. Gradually applied load means the magnitude of the load will gradually increase. होता है. When the magnitude of the load is going to be gradually increases, the magnitude of internal resisting force also going to be gradually increased. So stress is going to be a variable. Stress is a variable. But stress is a property of a material. Stress is a property. Material to material, the properties are going to be changes. Material to material, the properties are changes. So to bring out a comparison between stress and strength, both are having the same unit. Now ये दोनों बीच में comparison को करने के लिए मैंने एक similar example ले रहा है. I'm taking a similar example to compare the what? To compare the stress and strength. Assume a person is going on a national highway. A person is going on a national highway on a bike. A person is going on a national highway on a bike. His bike speed can vary from 0 to 100 kmph. The bike speed can vary from 0 to 100 kmph. Now, my condition is what my question is, at what speed, at which speed, this person has to drive the bike so that he will reach the destination. He will reach the destination within a less time and safely. Are you getting it now? Now, stress and strength are about the same units now, but they both are different now. Now, उसको compare करने के लिए, then I'm taking a similar example about a person is going on a national highway. National highway, NH104 example, going on a national highway. The bike speed can vary from 0 to 100 kmph. Now, my question is, at which speed we should ride the bike so that we will reach the destination within a less time and safely? Can you give me what is the answer for this question now? Already I mentioned, my dear friend, there were power issues are there. Frequently power is going on, coming on. At the time it is running on the generator.
Force upon area.
So some issues there from today. Now can you give me the answer now? The person should ride the bike at which speed? The bike speed can vary from 0 to 100. But my question is, at what maximum speed he should ride the bike so that he will reach the destination safely and within a less time. He should reach the destination safely and within a less time. If there is no safe condition, then he should go up to 100 kmph now. It is dependent upon the strength of the bike. My dear friend, mic is proper. Don't repeatedly mention it now. Mr. Dinesh, here everything is fine. You have to check from your end now. Don't repeatedly mention the same thing now. Sir, mic change करो. हम चेक किया था. आपके साइड से प्रॉपर चेक करो. कितना बार आपका बात सुन के मैंने टेक्निकल टीम को जब उन लोगों को पूछा था, उन लोगों ने मेरा बात सुन लिया था. Audio is fine. Somebody given approximately 60 to 70 kmph. Average speed less than 100 at about 60 to 80 kmph. They are not the correct answer now. 70 kmph. Mohammed Danish, 70 kmph. You should reach safely, and you should also reach the destination within a left hand. So my question is, at which maximum speed you should ride the bike? Safety factor is required. Tell him to restart device. Anybody got the answer now? The bike speed is about 0 to 100. You can go 100 now. But the condition is what now? You should reach the destination safely within the left hand. So at which maximum speed you should ride the bike so that you will reach the destination within the left hand. Nobody has given a proper answer now.
Question भी क्या?
45, 50. Go 45 what happens now? He may not reach the destination within the left hand. If you go at a 40 what happens now? He says, but he's not going to reach the destination within the left hand. He's not going to reach the destination within the left hand now.
अब मेरे को समझाओ हाईवे पे.
If you go for 100 what happens now? If you go 100, you may reach the destination within the left hand, but you may not be safe now. Both the conditions are required now. You should be safe and you should reach the destination within the left hand. What the condition now? Always on a national highway, limiting speed is going to be mentioned. On any national highway, limiting speed is mentioned. As in NH 104, limiting speed is 80 kmph. What the meaning of this now? So whoever is going on that national highway, whoever is going, whatever with the bike, whoever is driving, all the bike speed should be what now? Should be less than or equal to 80 kmph. Only safe means what now? Less than 80 kmph. But you should also reach the destination within the left hand. So that person should drive the bike at 80 kmph because that is the maximum safe speed. Whatever with the bike, who is the manufacturer and who is the driver now, who is the rider now? All the bike speed should be less than or equal to 80. So that person should drive the bike at 80 kmph. Now in this case, how many speeds are there? There are two speeds are there. One is the bike speed, one is the limiting speed. Both are in the same unit. Bike speed is also kmph, limiting speed is also kmph. Units are same, but both are different. Bike speed is a variable. It depends on the what now, which bike, who is driving the bike. Bike speed is a variable. But limiting speed is what now? But the given road, the limiting speed is a fixed now. So now, which can be out of these two speeds now? Bike speed and limiting speed. Which can be correlated as a swell and which can be correlated as a swell. Bike speed should be considered as a swell. Bike should be correlated as a swell. Swell is what you have said now? Variable. Bike speed is a variable. Bike speed depends upon which bike and who is driving the bike. Swell is also depend upon the what now? How much load is applied and what the area, cross-sectional area is to be there now. So swell is a variable. But for given road, limiting speed is fixed. Similarly, for a given material, swell is fixed. So in that example, bike speed should be correlated as swell because it's a variable. Limiting speed. Limiting speed should be correlated as swell. For a given road, limiting speed is fixed. Similarly, for a given material, the swell is fixed. As in what a person is going on a national highway, 80 kmph. Limiting speed is also 80. So it's going to reach the destination within the left hand and safely. But in between, coming on the center of the city. On the center of the city, limiting speed is 30 to 40 kmph. So once again, you have to reduce the bike speed up to 30 to 40. Road condition to road condition, limiting speed will changes. Similarly, material to material strength will changes. Material to material strength changes. For a given material, mile speed strength is different. Gas current strength is different. Once the material changes, wheel strength and ultimate strength changes. But for a given material, strength is going to be a constant. It's a property. Similarly, what a road to road condition what happens now? For a given road, limiting speed is fixed. But once a road condition changes, limiting speed is going to be changes. But stress is what depend upon the what? Bike speed depend upon the what? Which bike, who is driving the bike. But stress will depend upon the what? Load and geometrical properties, cross-sectional dimension. This will depend upon the what? Externally applied load and the cross-sectional dimension to be there. This is a variable. This is what? Constant. This is the property of a material. Both units are same. SI unit, whether we are following the SI unit, Pascal. Yes, they same units are same. kmph it could be used. Now for my speed. Most of your students, my material science is completed. There are 4-5 batches of students are here. Only the batch which is started on Saturday. But the material science is not completed. For remaining all the batches, mostly the material science I have already completed. Anybody tell what is the other name for my speed? So Ganesh is given the answer. It depends upon the limiting speed written on the national highway code. What's the other name for my speed? Anybody? My speed. Low carbon speed. Based upon the carbon percentage. 3 types of carbon speeds are there. Low carbon speed, medium carbon speed, and high carbon speed. Low carbon, medium carbon, and high carbon speed. So according to the carbon percentage, what's the other name for my speed now? LCS, low carbon speed. Medium carbon speed, NCS. If the carbon percentage is more, high carbon speed. Anybody can you know what the carbon percentage here now? What the carbon percentage? In my speed, what the carbon percentage now? Carbon percentage. 0.2 percentage. 0.4, 0.5 medium carbon speed, 0.8 and 0.9 will be high carbon speed. So your carbon percentage will be 0.2. But what is the commercial name for low carbon speed? What is the commercial name for my speed? Structural speed. Structural speed. Why not? All the structural application. mild steel is used as a reinforcing material. Concrete is about the brittle material. Concrete is a brittle material. Brittle materials are weak in tension. So to increase the strength of the concrete under tension, mild steel is used as a reinforcing. To take any concrete structures now, to take a column, wall, everywhere what a beam, any concrete structure, mild steel is used as about a reinforcing. Concrete is a brittle material. Brittle materials are weak in tension, strong in compression. So to increase the strength of the concrete under tension, the concrete is what a reinforced with the mild steel bars now. That's why the another name is what a structural steel. So what the other name for mild steel or structural steel? So for mild steel, what the properties now? SYT. SUT. SYT stands for what? S means strength, Y means yield, T means tension, yield strength in tension, and here SUT, ultimate strength in tension, ultimate strength in tension. Ultimate strength in tension. These are the property of mild steel. If I change the material once again, they will change now. So like this, how many have to be there now? SYT, steel means addition, ST. So for mild steel, what are the properties now? SYT. SUT. SYT stands for S means strength, Y means yield, T means tension, yield strength. Tension. And here SUT, ultimate strength in tension, ultimate strength in tension. Ultimate strength in tension. These are the property of mild steel. If I change the material once again, they will change now. So like this, how many have to be there now? SYT. SYT means yield strength in compression or crushing. SYS, yield strength in shear. Similarly, SUT, SUC, SUS, T means tension, T means compression, S means shear. U means ultimate. SUT means ultimate strength in tension. SUC means ultimate strength in crushing. SUS means ultimate strength in shear. Now these are obtained from stress strain curve, which is drawn by using tension test grading. The batches which are what a completed material science. Already the stress strain curve was discussed by your material science teacher is already discussed. So I'm not going to explain the stress strain curve. When I'm discussing the resilience, toughness, I'm going to draw the stress strain curve. But I'm going to draw the stress strain curve only elastic region. Only elastic region I'm going to discuss because in strength material are dealing with the elastic region now. But total stress strain curve, that is what elastic, elastoplastic, plastic region, total stress strain curve are going to be studied in the material science. All the tests, tension test, hardness test, impact test, all these tests are covered already in the material science. Only fatigue test is going to be studied in the material science, sorry, mission design. But strength material, I'm not explaining all this tests. All these tests are going to be explained by your material science teacher. But some students, though we have joined recently, maybe last 2 or 3 batches now, material science might not have been completed. But most of majority batches material science is completed, already you have read the stress strain curve. So we are joined a little bit late, for them material science is covered separately where your material science teacher is going to explain the stress strain curve. So these two are obtained from the what now? Normal stress versus longitudinal strain curve, which is drawn by tension test grading. These are obtained from the stress strain curve, which is drawn by tension test grading. Now, what is value representing? What is value representing? What is strength of a maximum stress that the material can withstand without a failure or fracture? What is the meaning of this now? This mild steel is able to withstand a maximum stress of how much? 250 without undergoing yielding. Without undergoing yielding means without undergoing complete permanent deformation. But when stress induced more than 250, what happens? When stress induced more than 250, material is going to be completely plastic. Then the material will behave like a perfect plastic. And what about the ultimate stress in tension? Ultimate means what now? This is the maximum stress the mild steel can withstand under tension test. Without a fracture. With the stress induced, just now you studied the variables, these are the properties. If the stress induced is greater than SUT, fracture will occur. If it is greater than 250, it will go into plastic region. Completely plastic deformation is there, completely plastic now. So what the yield stress definition you have to study? What the yield stress definition? Same definition. Maximum stress that the material can withstand without undergoing yielding. Yielding is a representation of what the way material goes into completely plastic deformation, means it will not regain any of the dimension. So as long as the stress induced means up to 250, there is no completely plastic. Up to 250 what? It will undergo what? Elastoplastic. Greater than 250, it will undergo yielding. So what is the meaning of this now? Some students are going to ask that yielding क्या है? Yielding बोले तो where material goes into completely plastic. You completed metal forming also you studied total metal forming. When a sheet metal passing through a rolling mill, a sheet metal rolling mill से pass होने के time पे क्या चाहिए? Rolling mill should apply the load such that the stress induced in the sheet metal should be more than 250. If a mild steel sheet is passing through a rolling mill, then sheet metal should undergo permanent deformation.
अगर कोई देख रहा है तो मैं टाइमर खत्म होने के बाद में चैट देखूंगा। तो
शीट मेटल रोलिंग मिल के पास होने के टाइम पे शीट मेटल शुड अंडरगो परमानेंट डिफॉर्मेशन मींस द रोलिंग मिल शुड अप्लाई a load such that the stress induced in the sheet metal should be greater than 250. A mild steel sheet is passing to a rolling mill. Then at that time the mild steel sheet should undergo permanent deformation. Then at that time the stress induced in mild steel sheet should be greater than 250. Greater than 250. Then it will undergo yielding. Yielding is a representation of where material goes into completely plastic. That material will behave like a plastic. And what are the condition now? Stress induced will be less than 400. We have to apply a load. The rolling mill should apply a load such that the stress induced in the sheet metal should be greater than 250, less than 400. Greater than 250 means it will undergo plastic, but less than 400 means the sheet metal will not fracture. But when it should be more than 400, suppose you go for punching application. In punching application, what the aim of the punching now? You have to make a hole in a sheet metal. You have to make a hole in a sheet metal. In that case, the punch should apply a load such that the stress induced in the sheet metal should be, which failure will occur, the shear failure will occur. So the sheet metal, the load applied on the punch will become a shear load for the plate. In that case, the shear stress induced in the sheet metal of the plate should be greater than ultimate stress in shear. Ultimate stress in shear. This is what a sheet metal with a load. This is a punch. This is a punch. This is a sheet metal. But you are applying a load like this now. So the load applied on the punch should be in such a way that the shear stress induced in the plate. Here shear failure is required now. The sheet metal should shear off. The load applied on the punch should be in such a way that the shear stress induced in the punch should be greater than ultimate stress in shear. Which stress I have to consider now? SUT or SUP or FUS. If a tensile load, you are going to get a tensile stress. Then you take the SUT. If you apply a shear load, then you are going to get a shear stress. Then you have to take the SUS. If shear stress induced means shear load is applied. Under shear load, you are going to get a shear stress. Then in that case, if the shear failure should occur means what? Shear stress should be greater than SUS. So in sheet metal operation, in case of sheet metal operation, what the requirement now? Stress induced should be greater than 250, less than 400 required. Or greater than yield strength, less than ultimate strength. But in punching application, it should be more than ultimate strength. Ultimate strength. Ultimate strength in tension or shear or compression. Ultimate strength in tension or compression or shear. In case of punching application, that load will become a shear load. In the plate, you are getting a shear stress. Then the shear stress should be greater than SUS. Ultimate strength in shear. Same thing here. Fracture will not occur. Now these two are obtained from tension test. That is about a stress versus strain curve drawn by using tension test. These two are obtained from both a stress versus strain curve drawn by using compression test. And these two are obtained from both a stress versus strain curve. That is about a shear stress versus shear strain curve drawn by using torsion test. Torsion test. These are obtained from the both stress versus strain curve drawn by using tension test theory. These are obtained from the stress versus strain curve drawn by using compression test. And these are obtained from the stress versus strain curve drawn by using torsion test. But your material test, you are studying the only tension test. This specific compression test is studied by civil engineering students. Compression test is studied by the civil engineering students. And this is obtained from the torsion test. But which material will exhibit both yield and ultimate? Which material will exhibit both yield and ultimate strength? Which material will exhibit both yield and ductile material? Ductile material. Ductile material only permanent deformation will occur. But brittle material, there is no permanent deformation. Brittle material directly will fracture. So brittle material will exhibit only ultimate strength. Ductile material. What is the meaning of ductile material? It will exhibit considerable permanent deformation before the fracture. Ductile, more ductile means what? A material more ductile. Low carbon steels are more ductile than medium carbon steels. Medium carbon steels are more ductile when compared to high carbon steels. More ductile means that material will exhibit more permanent deformation. So only ductile material will exhibit both yield and ultimate strength. But brittle material, cast and the brittle material. Brittle material, there is no permanent deformation. Brittle material will exhibit only ultimate strength. Brittle material will exhibit only ultimate strength. So in the question, how to decide that ductile or brittle material? How to decide this ductile or brittle material? Based upon the input data, if yield strength and ultimate strength both are given with the ductile material, only ultimate strength is given with the brittle material. Whenever yield strength is given with the ductile material, if only ultimate strength is given with the brittle material, brittle material will exhibit only ultimate strength. There is no yield strength. Brittle material means they will not exhibit any permanent deformation. But ductile material will exhibit permanent deformation. More ductile means it will exhibit considerable permanent deformation before the fracture. So mild steel is more ductile. Medium carbon steel. So the carbon percent increases, as the carbon percentage increases, ductility will decrease. brittleness increases. That is, permanent deformation will decrease. Permanent deformation will decrease. So sometimes this information required in series of failure. In series of failure, chapter required. Most of the students are ductile material, maximum shear stress theory and distortion energy theory use. Brittle material, maximum principal stress theory use. Then how to decide which theory as use it now? Is it ductile or brittle material? Every time type of material is not going to be given now. They are going to be this now. So based upon the input data, if only yield strength is given, or yield and ultimate both are given with the ductile material. If only ultimate strength is given with the brittle material. Only ultimate strength means brittle material. So these were obtained from tension test. These were obtained from torsion test. These are obtained from compression test. Then the compression test is studied by the civil engineering students now. In punching, if the induced strength greater than the ultimate strength, would not the material break? Material will shear off. Material will exhibit any permanent deformation. But ductile material will exhibit permanent deformation. It will exhibit a considerable permanent deformation before the fracture. Ductile, more ductile means what? A material more ductile. Low carbon steel are more ductile than more ductile means that. So only ductile material will exhibit both the yield and ultimate strength. But brittle material. Now these two are obtained from tension test. That is about the stress versus strain curve drawn by using tension test. These two are obtained from both the stress versus strain curve drawn by using compression test. And these two are obtained from both the stress versus strain curve. That is about the shear stress versus shear strain curve drawn by using torsion test. Torsion test. Strain curve drawn by using torsion test. Torsion test. The strain you are obtained from both the stress versus strain curve. That is what shear stress versus shear strain curve drawn by using torsion test. Torsion. These are obtained from the what now? Then how to decide which theory as use it now? Is it ductile or brittle material? Without undergoing yielding. Ultimate strength, what should I write? Ultimate strength, what maximum strength that material can withstand without a fracture. Without a fracture. So nothing is mentioned. Strength means default you have to go for ultimate strength. Default strength of the material means ultimate strength. Default strength of the material means ultimate strength. And elastic constant. I'm in the short form of EC. During my lecture, EC means elastic constant. How many elastic constants are there in the Young's modulus? Modulus, bulk modulus, Young's modulus. Modulus EGK. E stands for Young's modulus, G stands for shear modulus, K stands for bulk modulus. All are in the unit. Okay. Strength and elastic constant units of phase. So during my lecture, EC I'm using for elastic constant. What the actual unit for the stress now? Pascal. Presently you are calling the SI unit. SI unit is Pascal. But in the Pascal we are using the megapascal. Then the gigapascal is for the elastic constant. Next. Presently we are following Pascal only SI units now. But still some of the engineering service papers, all the gate papers they are using the Pascal, megapascal they are using. But some of the engineering service papers still they are taking the question from the very old textbook. They are using the MKS unit, the MKS unit, kgf or k square. SI unit. But some students in place of capital M they are going to write as a small m. Small m means milli. Your capital M is mega. So you should be careful. Capital M is mega. Mega is for 10 power 6 now. But some students are going to the small m. Small m is what? Milli. 10 to the power -3. So you should be careful now. So most of you already know you have completed the fluid mechanics also. 1 Newton per meter square. But this is equal to 1 megapascal means 10 power 6 pascal or 1 Newton per mm square. 1 Newton per mm square. Gigapascal. So this is equal to so 500 gigapascal means directly can write down 510 to megapascal or 500 into 10 power 9. So you have to decide it now whether you want to go for Newton per meter square or Newton per mm square. But everywhere I mean the Newton per mm square. Most of the machine design textbooks are using the Newton per mm square because machine components are very very small. Shaft diameter 50 like this, bolt diameter 20, 30, 100 millimeter. So most of the machine design textbooks are using the Newton per mm square. But conformative textbooks are using the Pascal, they are using the Newton per meter square because machine for structural components for the beam, column, they are all what the dimensions are very large now. So they are using the Newton per meter square. You can use any one unit, but everywhere I am calling the Newton per mm square. I am assuming the cross-sectional dimension. I am assuming the cross-sectional dimensions are in mm. Substitution of proper very important now. Substitution support now. This is not all the things. That guys what a 10 power 9 sir. Pascal is Newton per meter square. 1 meter is 1000 mm. Don't waste your time for unnecessary things. Directly 100 gigapascal means either write down 100 into 10 power 9. If you want to, if you assume the cross-sectional dimensions are in meters, if you assume the cross-sectional dimensions are in mm, then directly put it 100 into 10 cube Newton per mm square. So you should not waste your time in simple things. Now directly you write down 1 kg per cube square. This is a MKF unit. This will be 0.1 megapascal. If you assume the kgf equal to 10 Newton, then the 1 kgf equal to 9.81 Newton. But generally you are assuming actually 9.81 Newton. Now for example, my speed just now you written. Then the stress is written in terms of megapascal. Elastic constants are written in gigapascal. But stress you have to calculate now. This one is given input data. SYT and SUT. Material properties are given as input data. So generally SYT and SUT is given in terms of megapascal. Elastic constants also given as input data. They are given in gigapascal. But stress has to be calculated. Now you want to use the pascal or megapascal. Depending upon what is the cross-sectional dimensions are in mm, use the Newton per mm square. If the cross-sectional dimensions are in meters, then you go for Newton per meter square. Try to remember at least material properties, not examination point of view. All the gate examination, engineering service examination, especially gate is not a test for memory power. All the material properties, Young's model, year model, bulk model, mass density, weight density, coefficient of thermal expansion, all the material properties are given as input data. But the student has to remember the geometrical properties. Student has to remember the geometrical properties. Which are the geometrical properties now? Area, first centroid. Next area, next moment of inertia. How many moment of inertia are within a 3? I about XTA, horizontal centroidal axis. I about vertical centroidal axis. I about polar axis. Actually, the moment of inertia, 2 moment of inertia are there, area and mass moment of inertia. Total strength of material dealing with the area moment of inertia. But your dynamics, total strength of the static subject only. Indian mechanics is classified statics and dynamics. In dynamics, you are going to use the dynamics in theory of machine. You are in the mass moment of inertia. But total strength of the statics only. So here you are in the area moment of inertia. Moment of inertia classified into 2 types now. Area moment of inertia, mass moment of inertia. In the entire subject, you are dealing with the area moment of inertia. How many A's? Type of subject. Apical X moment next A. It's the property. Now in T and SS. Assuming actually 9.81 Newton. Now for example, then you go for Newton per meter square. Try to remember at least material properties, not examination point of view. All the gate examination, engineering service examination, especially gate is not a test for memory power. All the material properties, Young's model, year model, bulk model, mass density, weight density, coefficient of thermal expansion, all the material properties are given as input data. But the student has to remember the geometrical properties. Student has to remember the geometrical properties. Which are the geometrical properties now? Inertia, all this. But total strength of statics only. So here you are in the area moment of inertia. Moment of inertia classified into 2 types now. Area moment of inertia, mass moment of inertia. In the entire subject, you are dealing with the area moment of inertia. How many area moment of inertia are there? 3. One moment of inertia, HCA. HCA stands for horizontal centroidal axis. BCA stands for vertical centroidal axis. PA stands for polar axis. So first you have to locate the centroid. If a triangular cross section is what the centroid now. One side from the base, 2 sides from the vertex. So first you have to locate the centroid. And through the centroid there are 3 axes there. One is the HCA, BCA, polar axis. So all the geometrical properties. We go by triangular section is given. What the center rod now? H by 3 from the base of the triangle to H by 3 from what? That has to be remembered. Next, what is the moment of inertia of a triangular section about the neural axis? PH cube by 36. About the base of the triangle, PH cube by 12. And section modulus, PH square by 24. So all these geometrical properties have to be remembered. In the exam, they are going to give only the shape of the cross section is given. If a circular section is given, center rod is exactly the center. Area, pi d square by 4. Moment of inertia, pi d to the power of 4 upon 64. Polar moment of inertia, pi by 32 into d to the power of 4. Polar section modulus, pi by 16 d cube. So material properties are given in the question. You need not remember. But geometrical properties, area, centroid, moment of inertia, section modulus, polar section modulus, all has to be remembered by the student now. Student has to be remembered now. So, but sometimes I might still try to remember the properties now. Yield strength, ultimate strength, and ink modulus. Generally, when you are going for infinite, I might still mostly use now. Ink modulus. Now, what the student has to do it now? One student has to write down directly what he can write down now. And another student can write down what now? 250 into 10 power 6. Now we have to consider this now. If the student has considered what a Pascal, if cross-sectional dimensions are in mm, then you go for what a Newton per mm square. If the stress units are megapascal, then it also should be Newton per mm square. If you have the cross-sectional dimensions are in meter, if the stress is Newton per meter square, then stress also should be Newton per meter square. So this unit you can write down decided based upon the stress unit now. Just now you are studying stress will be less than or equal to yield stress, there should not be a permanent deformation. If the stress induced is what Newton per m square, then this also should be Newton per m square. If the stress induced you consider is Newton per meter square, then directly you write down the 215 to 10 power 6. Similarly, what you can write down now? If you consider the Newton per m square, then directly what the H model you write down now? And in place of Newton per m square, you can write down the megapascal. And here, if you consider the stress is what a Pascal, then yield stress of the Pascal, then H model should be there is not a giga 10 power 9. Then Pascal is what a Newton per meter square, 1 meter is 1000 mm. Directly write down. If cross-sectional dimensions are mm, use these two. If cross-sectional dimensions are meters, then you can go for this.
भाई मास्टर को ड्राइंग नहीं है जम रही। क्या टाइम लगा रहा है भाई मास्टर।
Identical bar means same dimension, same length and same cross-sectional dimension.
अच्छा वो लाइव क्लास नहीं है मेरे पास, रिकॉर्डेड है। रिकॉर्डेड कम से कम फॉरवर्ड तो करते था।
What the difference in three bars now? All are having got the same length, same diameter, same length, same diameter. But what is the difference? The loading condition is different. Now what change you are going to get in the three bars now? What is the difference in three bars? All are having got the same length, same diameter. But loading conditions are different. Now what difference you are going to observe it here? Now what is the difference you are going to observe it? Here load is applied only in one direction. Here this bar is got pulled with the two equal and opposite axial load. This load is called the axial load. This axial called the longitudinal axis. This axis longitudinal axis. So when the load is acting along the longitudinal axis, axial load. Here axial load is applied only in one direction. Here the compressive load is applied. But here two equal and opposite tensile loads are applied. Two equal and opposite tensile load. But here two unequal and opposite tensile load. One tensile load is P, another tensile load is 2P. So this bar will undergo only displacement. Starting what now, day before yesterday, this will undergo only displacement. The bar is what as it is displaced into another position. There is no change in dimension. There is no change in length, there is no change in diameter, only position is changed. Then the bar is going to be considered as about a rigid body. This bar is considered a rigid body. It will undergo only displacement, there is no strain. What about this bar now? This is what now? This load is going to be what now? Pull this bar towards left side. So A will move towards left side. And because this load B will move towards right side. So A and B what now? A moves towards left side, B moves towards right side. So distance between A and B increase. Dimension will change. In the previous case, there is no change in dimension. Initially, what the distance between A and B L. Even after applying the load, also distance between A and B L. There is no change in relative position. Relative position of the particles are same. That is going to be displacement. Initially, here, what the distance between A and B L. After applying the load, what the distance between A and B will be increased. So this will undergo deformation. So length will increase, diameter is going to be decreased. I'm assuming the default Poisson's ratio is going to be non-zero. Length will increase, diameter will decrease. If the Poisson's ratio is zero, only length will change. So this will undergo only deformation. This will undergo only displacement. What about this now? This 2P. I mean, what the conclusion now? Whenever you want to get only deformation, what is required now? Two equal and opposite loads are required. Two equal and opposite loads. But when the load is applied only one direction, only displacement, then the member is treated as a rigid body. But here, two unequal and opposite. P towards left side, 2P towards right side. Two unequal. Now this 2P can be written as what of P plus P. We can consider this 2P as what of P plus P. So because this P and P, what the length will increase, diameter will decrease, deformation will be there. And because this additional force P, what the displacement will be there. So this member will undergo what now? Both deformation and displacement. This will undergo only deformation. This will undergo only displacement. Next, what is the another difference now? The second member is static equilibrium. Some of the forces are zero. Some of the forces are zero. Some of the couples are zero. This is static equilibrium. But what about the 1 and 3? They are in dynamic condition. Here some of the forces are not zero. But some of the forces are P. But some of the forces are P. So here this 1 and 3 are in what dynamic condition. But 2 is in what static equilibrium. So overall strength material comes under which now? Second one. Now out of these three now. So the second one is assumed in the strength material. It is a prismatic bar made of same material and it is under static equilibrium. So total strength material deals with the second case. So what the conclusion now? Whenever you want to get a deformation, you have to apply the two equal and opposite loads are required. But if you apply the two unequal and opposite loads, it will undergo both deformation and displacement. But here only displacement will be there now.
क्या स्लो मास्टर है भैया, इसको डिजिटल बोर्ड यूज़ नहीं करते आता शायद. इसको तो ब्लैक बोर्ड ही देना चाहिए था, डिजिटल बोर्ड दे दिए टाइम वेस्ट करने के लिए.
Between A dash and B dash, it will be the same. Treated as a rigid body. Remain same. Relative position of the particles will be remain same. But what about the second bar? What about the second bar? A will move towards left side, B will move towards right side. So length is going to be increase and diameter is going to be decrease. The bar remains same, but your relative position is changes. Now what about this distance now? I'm assuming the P is not. So this bar will undergo deformation. But which deformation you are assuming now? So this I'm assuming the P is non-zero. I'm assuming the length will increase, diameter will decrease. So this bar will undergo deformation. But which deformation you are assuming now? If I remove the load, once again A dash will come to A and B dash will come to B. So it will undergo elapsed deformation. If this B dash reaches what now? As long as the P is acting, B shifted to B dash and A shifted to A dash. If I remove the load gradually, this load is gradually increase from 0 to P. When the load is gradually increase from 0 to P, gradually P will shift to the B dash and A will shift to the A dash. And if this load is gradually removed, then once again A dash will come to A and B dash will come to B. Means it is undergoing what now? Elastic deformation. If the B dash will not reach the B, if the B dash will come to here now, then it is called the elastoplastic now. But if the B dash neither shift towards left side, B dash will remain same. Even if the load is acting, even if the load is removed. When the load is acting, when the load is B shifted to B dash. Even if the load is removed, B dash will remain here only. Then it is called what now? Completely plastic. If the B dash will reach the B, then it is completely elastic when the load is removed. But when the load is removed, B dash will not move towards left or right. B dash will remain here now. Then it will be what now? Completely plastic. but the B dash reaches towards left side but will not reach the B. Somewhere it will be there. There is what? Elastoplastic. But entire conformity we are dealing with what? Elastic. Elastic means what? B dash will reach the B. Means what the condition? The stress induced should be what? The stress induced should be less than or equal to elastic limit of the material. Less than or equal to elastic limit of the material. This is only a conformative subject. This is only deals with the conformative subject. Second bar
undergoes
only elastic formation.
Elastic deformation.
Only elastic formation. Means that is only means what there is no displacement. Only elastic formation. That is when this undergo elastic formation. That is stress induced will be less than or equal to elastic limit. Stress induced is less than or equal to elastic limit. So whenever you want to get only deformation, what the condition? Two equal and opposite loads are equal. Two equal and opposite loads. But here what are two unequal and opposite loads. Because this 2p is what 2p can be written as p plus p. So because the p and p what happens, length will increase, diameter will decrease. And because this additional force p what happens, displacement. So in this case what happens, position will change and dimension will change. So this only is nothing but the conformative subject. And here what you are going to get is now. If I am asking to the x direction, in this x direction what will be there now? Dimensions are changing, strain is there and stress is there. In the x direction, if I take in the x direction, stress and strain both are there. The strain in this direction is part of the longest strain. But if I assume this direction, what y and z what now? There is strain is there because the Poisson station non-zero, but there is no strain. So there is no stress. Y and z direction there is no stress. So stress is developed only in one direction. So it is called a uniaxial state of stress. What is the meaning of uniaxial state of stress? Stress is developed only in one perpendicular direction. Other two perpendicular directions, stress is zero. So here the normal load, shear load, normal load. Which type of normal load? Axial load. So normal stress in this direction, x direction. And this normal stress due to axial load. So the axial stress, sigma A. Sigma A means what now? Axial stress. That is the normal stress due to axial load. This is the what now? For the here now. P by A. What the P now? P is not a load. P is the internal resisting tensile force. But the equilibrium condition P and F is not a load. It is the internal resisting force. Just now you studied now. But when the equation is valid, when the stress is uniformly distributed, when stress is uniformly distributed, for the actual equation here limit delta A tends to delta Fn by delta A. But you are writing P by A means on entire cross section stress is uniformly distributed. But on which cross section stress is uniformly distributed now? On which cross section stress is uniformly distributed? On the cross section far away from the load. So if you consider cross section near to the load, if you consider cross section near to the load, stress is non-uniformly distributed. The stress is always uniformly distributed on a cross section which is far away from the line of action of the load. But we consider cross section near to the line of action of the load. It is parabolically distributed. Then we cannot use this formula. So this formula is going to be valid on which cross section now? Which are far away from the line of action of the load. A scientist trained Benon to prove that axial stress is uniformly distributed on the cross section far away from the line of action of the load. But if we consider cross section near to the not the cross section, if we consider here now, here this formula is not valid because it is parabolically distributed. It will be maximum at the center as you are going away from the line of action of the load, it will be decreases. So in this case it is not valid. So always somebody will ask axial stress uniformly distributed or non-uniformly distributed. Every time you are writing the axial stress equal to P by A. This equation is valid on the cross section which are far away from the line of action of the load. If you consider cross section nearer to the line of action of the load, it is parabolically non-uniformly distributed. In that case this formula is not valid. This is proved by a scientist named Benon. Benon proved that when a bar is subjected to axial load, stress is uniformly distributed on the cross section far away from the line of action of the load. Far away from the line of action of the load. If the cross sections are nearer to line of action of the load, this formula is not going to be valid because the stress is non-uniformly distributed. The parabolic variation will be there now. Then what does stress in y and z direction now? Because load in y and z direction will be zero. Load in y and z direction is zero. Now this is called the uniaxial state of stress away from the line of action of the load. If the cross sections are nearer to line of action of the load, this formula is not going to be valid because the stress is non-uniformly distributed. The parabolic variation will be there now. Then what does stress in y and z direction now? Because load in y and z direction will be zero. Load in y and z direction is zero. Now this is called the uniaxial state of stress. This is called the uniaxial state of stress. So somebody will ask what is the meaning of uniaxial state of stress? When stress is developed only in one perpendicular direction. But most of the times what uniaxial state of stress means stress एक ही डायरेक्शन पे डेवलप होता है, वो गलत है. यूनिएक्सियल स्टेट ऑफ स्ट्रेस मीन स्ट्रेस एक परपेंडिकुलर डायरेक्शन पे डेवलप होता है. कितना परपेंडिकुलर डायरेक्शन रहता है? एक पॉइंट पे 3 परपेंडिकुलर डायरेक्शन. एक्स वाई जेड आर 3 म्यूचुअल परपेंडिकुलर डायरेक्शन. एक्स वाई जेड आर 3 म्यूचुअल परपेंडिकुलर डायरेक्शन. तो स्ट्रेस इधर भी एक ही परपेंडिकुलर डायरेक्शन पे डेवलप हो जाए तो उस कंडीशन को यूनिएक्सियल स्टेट ऑफ स्ट्रेस कंडीशन बोलेंगे। इफ स्ट्रेस इज टू परपेंडिकुलर डायरेक्शन पे डेवलप हो जाए तो उसको बायएक्सियल स्टेट ऑफ स्ट्रेस कंडीशन बोलेंगे। इफ स्ट्रेस तीन परपेंडिकुलर डायरेक्शन पे डेवलप हो जाए तो उसको ट्रायक्सियल स्टेट ऑफ स्ट्रेस कंडीशन बोलेंगे।
uni by tri, it will go elastic deformation, that is stress induced is less than elastic limit. Here load is acting in only one axis. तो ये क्या बोल रहे हैं words?
परपेंडिकुलर डायरेक्शन रहता है एक पॉइंट पे तीन परपेंडिकुलर डायरेक्शन एक्स वाई जेड आर थ्री म्यूचुअल परपेंडिकुलर डायरेक्शन एक्स वाई जेड आर थ्री म्यूचुअल परपेंडिकुलर डायरेक्शन। तो स्ट्रेस इधर भी एक ही परपेंडिकुलर डायरेक्शन पे डेवलप हो जाए तो उस कंडीशन को यूनिएक्सियल स्टेट ऑफ स्ट्रेस कंडीशन बोलेंगे। इफ स्ट्रेस इज टू परपेंडिकुलर डायरेक्शन पे डेवलप हो जाए तो उसको बायएक्सियल स्टेट ऑफ स्ट्रेस कंडीशन बोलेंगे। इफ स्ट्रेस
Here stress is developed in only x direction, therefore this is called
तीन परपेंडिकुलर डायरेक्शन पे डेवलप हो जाए तो उसको ट्रायक्सियल स्टेट ऑफ स्ट्रेस कंडीशन बोलेंगे। Your syllabus is restricted to biaxial state of stress condition, but here why you are getting a uniaxial state of stress condition? Because load is acting in only in one perpendicular direction. If the bar is going to be pulled towards left and right and pulled top and bottom, then the load is acting in x direction and y direction, x direction and y direction. Then stress is developed in two perpendicular direction. It is a biaxial state of stress.
if two perpendicular directions में stress act हो रहा, then it is biaxial stress condition.
The uniaxial means stress is not developed in one direction. Stress is developed only in one perpendicular direction. Means other two perpendicular direction is zero. Biaxial state of stress means not stress is developed in two directions. Stress is developed in two perpendicular direction means third direction is zero. Third direction is zero. At a point, how many directions are there? Na infinite directions are there. But how many perpendicular directions are there? Na three. If the stress is
ठीक है वही it is one of the three perpendicular directions.
stress एक perpendicular direction पे develop हो जाए तो मीन बाकी दो perpendicular direction में zero हो जाए तो उस condition को uniaxial state of stress condition बोलेंगे। If stress दो perpendicular direction पे develop हो जाए तो third direction पे zero हो तो उसको biaxial state of stress condition बोलेंगे। So uniaxial state. But what about the strain now? Dimensions are changed in x direction or y direction or z direction. X direction which dimension then a length. X direction also dimension is changed. Means strain is there in x direction. Y direction also dimension is changed. Diameter is changed. This is what x, y and z. Y direction which dimension is there? The diameter. Z direction also diameter is there now. So your deformation is there in how many direction now? X direction is there. X direction length is changed. Y direction also diameter is changed. Z direction also diameter is changed. So strain is there about three direction. So the axial state of strain. So when a bar is subjected to axial load, when a bar is subjected to axial load, uniaxial state of stress develop हो जाता, uniaxial state of stress develop होता है, but triaxial state of strain develop होता है. Stress is in one direction, but strain is there in three direction. So you are going to get a uniaxial state of stress and triaxial state of strain is developed. But everybody is going to contradict. When stress in y and z direction is zero, then how we are getting a strain now? Why stress is zero? Because load is zero. When there is no load, there is no stress. But why you are getting a strain now? Because the lateral strain. Why you are getting a lateral strain? Because the Poisson's ratio is going to be non-zero. By chance, is Poisson's ratio zero? If the Poisson's ratio zero, there is no change in diameter. Only length will change. Only length will change. then you are getting strain is there only in one direction. So when you are going to get about under pure axial load, when you are getting a uniaxial state of stress and uniaxial state of strain, when Poisson's ratio is going to be 0, when Poisson's ratio is 0, stress is there in one direction, strain is there also in one direction, then you are getting uniaxial state of stress and uniaxial state of strain. But when Poisson's ratio is not 0, you are getting a uniaxial state of strain and triaxial state of strain.
बाप रे, इतना सारी इन्फॉर्मेशन है, बस 2 मिनट में भूल देता। उसको लिखना तो इतनी बड़ी टास्क रहता। इफ म्यू इक्वल टू 0 then and if uniaxial stress condition is there, then uniaxial strain will develop. And if mu is not equal to 0 and if uniaxial stress condition is there, then triaxial strain will develop.
Default if nothing is mentioned, we are assuming the Poisson's ratio is non-zero. Poisson's ratio for every material is non-zero except starch.
For Poisson's ratio, भाई Poisson's ratio कहाँ लिखा हूँ मैंने? मिल गया।
Here MSQ question आने की chances है. A bar is subjected to pure axial load. Then which of the following statement is or true? First statement is uniaxial state of stress is developed. Next, triaxial state of strain is developed. Next one is what? Either uniaxial state of strain or triaxial state of strain may be developed. Last one is biaxial state of strain is developed. In this case, which statements are correct now? A bar is subject to axial load. First statement is what now? Uniaxial state of stress is developed. That is the correct. Second statement is what now? Triaxial state of stress is developed. Triaxial state of strain is developed. Third statement is what now? Either uniaxial state of strain or triaxial state of strain is developed. Last one is what now? Biaxial state of strain is developed. So which statements are correct now? A and C. But everybody is going for A and B. When the B is correct now? When Poisson's ratio is not there, is MSQ. So we don't know material. Material is not given now. So we can also go for a car. If it is a car, triaxial state of strain is not developed. But what about the third statement now? Either uniaxial state of strain or triaxial state of strain is developed. Both are correct. When uniaxial state of strain, when Poisson's ratio 0. When you are going to get a triaxial state of strain, when Poisson's ratio non-zero. In that case, you have to go for A and C are correct. But majority of the students they are going for what? A and B. When the material is not given, suppose given as a mild steel bar, a mild steel bar is subject to pure axial load. In that case, answer will be A and B. But when material is not mentioned, A and C are correct now. So you should be careful. But what about the strain now? Strain. What you are studying now is a normal load. Under normal load, you are going to get a normal stress. And the normal strain in the direction of the load is called a longitudinal strain. How to get this longitudinal strain? Using Hooke's law. Hooke's law will give the relation between what now? Stress and strain in the direction of the load. Last class you have studied now. Sigma x is proportional to epsilon x. And what the proportionality constant Young's modulus. So how to find out this now? P by KE. But what the normal strain you are studying now? Changing dimension to virginal dimension. This is by using Hooke's law. So the longirus plane is going to be determined by which elastic constant? The longirus plane is going to be determined by using Young's modulus. And what the other definition for a normal plane? Normal plane is changing dimension to original dimension. But in x direction, which dimension is there now? X direction, which dimension is there now? L. So in place of longirus plane, what you can also write down here now? So this also equal to delta L by L. Now from this one, what the delta L equation? Last class you written directly delta L equal to PL by AE. This is from what now? Law. And this is by using the normal plane definition. So from this one, what the change in length equation now? Next, for the normal strain in y and z direction, 0 or non-zero. The strain in y and z direction is called what? Lateral strain. Today starting your study now. For the lateral strain you are studying now. Lateral strain is the normal strain in a direction perpendicular load. Which directions are perpendicular direction of the load? Y and z. So the normal strain in y and z direction is called the lateral strain. But in y and z direction, which dimension is there now? Y and z direction, which dimension is there now? Diameter is there now. So this is equal to what now? Delta d by d. Delta d by d. Now this is known as unknown. This is unknown. Strength of it is a theoretical subject or experimental subject. Strength of it is a theoretical subject. How do you know that d, delta d? Delta d is written as what now?
अभी 10 मिनट का ब्रेक है, तो मैं मैसेज देख लेता कुछ आए क्या। हेलो ब्रो, और भाई क्या पढ़ रहे हो? हाँ भाई, लगे रहो, आप कुछ भी कर सकते हो। यूपीएससी तो मामूली चीज़ है। फोकस ओनली पर्सनैलिटी और डेली मॉक। यस। और कोई चैट में है क्या? अभी 10 मिनट का ब्रेक है यार, कोई बात करने कोई नहीं है। अरे हेलो, दिस इज़ ग्रेट, आई एम गेटिंग अ लॉट ऑफ माई स्टडी डन इन दिस लाइव स्ट्रीम, थैंक यू। अरे नाउ it is break time, 7 minutes break remaining, but no one is coming to chat. You know, whenever I used to talk, now that time lots of people used to come, but now there's no one. Is there anyone? Now this is break time. हेलो, 10 मिनट का ब्रेक है, 10 मिनट शायद, अभी 5 मिनट ही बचे। सब्सक्राइब कर दो, फिर 1 घंटा और पढ़ेंगे, फिर 10 मिनट का ब्रेक लेंगे। हेलो, मेरे को मालूम था ऐसा ब्रेक टाइम बोले तो कोई कुछ बोलता ही नहीं है, जब पढ़ते रहो तब मैसेज करते बैठते हैं। पढ़ने के बीच में डिस्टर्ब होता है। अरे राहुल, हाँ SM कृष्णा, कौन सा टॉपिक पढ़ रहे हो? मैं स्ट्रेंथ ऑफ मटेरियल। और ये सर ना बहुत लंबा एक्सप्लेन करते हैं यार, 4-4 6-6 घंटे की वीडियो लेक्चर है इसके। बोलो, कौन सा चैप्टर? ये तो फर्स्ट, अभी कल मटेरियल साइंस कंप्लीट हुआ मेरा, और अभी जस्ट फर्स्ट चैप्टर ही शुरू है। इसने कुछ बताया तो नहीं, इसने वो स्ट्रेंथ स्ट्रेस स्ट्रेन वो सब बताना शुरू कर दिया। रिजिड बॉडीज, डिफॉर्मेबल बॉडीज बता रहे। आई ऑलरेडी स्टडीड फ्रॉम हिम। अरे वाह, वैसे वो सर खतरनाक है, लेकिन ना वो बहुत मतलब बहुत सारी इन्फॉर्मेशन मुंह से बता देते हैं, और फिर मतलब वो थोड़ा लेंदी लग रहा मेरे को, बहुत ऐसा लग रहा बहुत लंबा खींच रहे क्या वो। नोट्स बनाया था मैं, है अप्रिशिएट मी अलॉट। अच्छा अच्छा, ऑफलाइन क्लास में थे क्या? ऑफलाइन में होंगे शायद। रिप्लाई आने को टाइम लगता है। तुम्हारा एमटेक बीटेक क्या हो गया है? अभी कॉलेज में हो? मेरा ना इसी साल बीटेक कंप्लीट हुआ मैकेनिकल इंजीनियरिंग से। तो मेरे को तो वैसे जॉब तो मिल रहा था, लेकिन मैं बोला कि डायरेक्ट अपन गवर्नमेंट सर्विस में लगेंगे। हाँ, अंडर ग्रेजुएशन बीटेक। बढ़िया डिसीजन है, हाँ। लगे रहो, अरे बिल्कुल। 1 मिनट ही बचा है अभी, फिर 1 घंटा पढ़ाई। थैंक यू थैंक यू। कितने साल सीनियर हो वैसे? 1 मिनट में फटाक से लिखना पड़ेगा। IIT बॉम्बे से एमटेक कर रहा हूँ। अच्छा, बढ़िया है यार, गेट में हम ताकत से स्कोर किए होंगे। चलो बढ़िया है। NPCL रह गया इस बार भाई। हाँ क्या? अरे फिर क्या अटेम्प्ट करने वाले हो क्या नेक्स्ट टाइम फिर से? अभी तो इंजीनियरिंग सर्विसेज के अंदर रेलवे की सीट ऐड किए और एग्ज़ाम की डेट जून में कर दिए, फेब में होती थी ना पहले। तुम भी देना मिले अगर नेक्स्ट ईयर इंटरव्यू में तो आ जाना ज़रूर, बिल्कुल। तुम भी देना मिलोगे तो चलो यार, ब्रेक ख़त्म। अभी 1 घंटे का टाइमर लगा, तो कुछ मैसेज कर रहे हो तो कर दो फटाक से। ऑल द बेस्ट। चलो थैंक यू। अभी रख रहा हूँ फ़ोन। ऑल द बेस्ट तक का देखा मैंने मैसेज। चलो
But D1 is known as unknown, D1 is unknown. How to find out this D1 by conducting the experiment, tension test. But it's not a tension test, confirmed subject is theoretical subject. Theoretical subject. Theoretically, we don't know. Again, initial diameter is 50. Final diameter is less than 50. But we don't know it's 45, 46. So D1 is unknown. So when the D1 is unknown, this one is unknown. Strain is unknown. Change in diameter is unknown. When the change in diameter is unknown, lateral strain is unknown. So theoretically, which one can be determined? Theoretically, what now? Stress is determined, strain is determined. We know the load and we know the diameter. We can find out the theoretical stress now. Theoretically, confirmed subject is theoretical subject. Theoretically, stress is determined. Strain cannot be determined. Similarly, here also what now? But the actual equation for the longer strain, change in length upon original length. Length will increase, but we don't know final length. How do you know final length? By conducting a tension test. L1 and T1 are known by conducting a tension test. Experimental is known. So when the L1 is unknown, delta is unknown. When delta is unknown, longest strain unknown. But how we are finding out the longest strain? By using the Young's modulus. Suppose we don't know the Young's modulus, we cannot find out the change in length now. So the longest strain is going to be determined by what now? Young's modulus. Similarly, here what the lateral strain is unknown because D1 is unknown. When the D1 is unknown, change in diameter is unknown. When the change in diameter is unknown, lateral strain is unknown. So what are actual longest strain? X direction. So this is the longest strain. What the normal strain in the direction of the load is the longest strain. What the longest strain? What the dimension is in L, delta L by L. Now this is known as unknown because L1 is unknown. But what is the other way can find out the longest strain? By using Young's modulus. Always theoretically which one can be determined now? Theoretically stress can be determined. Strain cannot be determined. Strain is determined experimentally by using the strain gauges. So always confirmative what is the first step now? First you have to find out the stress. Then you go for the first equation or second equation. First you are going to find out the stress. Then can you use this first equation or second equation? Second equation cannot be used. Why? Because L1 is unknown. You can use the equation because P is known, sigma is known, X modulus known. So what the next step now? Strain is determined. How to determine the strain now? By using elastic constant. So to determine the longest strain, which one is required now? X modulus is required. So Young's modulus is used to determine the longest strain. Once you know this value, once you know the longest strain, already know longest strain from here now. Then you can find out the delta L. So always theoretically what the first step now? Stress. First step is stress, then strain by using elastic constant. Then you are going to find out the deformation. Then you are going to find out the final dimension. So this is the first calculation. Then this is the second calculation. This is the third calculation. And from this one we can find out the L1 is determined. So what is the aim of the stress parameter report now? This is the first chapter now. First you have to derive the equation for the stress. Next you have to determine the strain by using elastic constant. Then you have to find out the delta L. If you know the delta L, then you can find out L1. Now this is which load you have taken, axial load you have taken. So chapter to chapter what change you are going to get it now? Total 10 chapters are there. In the 10 chapters aim is same, but chapter to chapter loading condition will change it. Chapter to chapter loading conditions are changed. In the first chapter you are having the load acting along the longest axis. In third chapter load acting perpendicular to longest axis. If the load is acting like this,
एक मिनट, एक पोल डालता हूँ। ये सही है। ये टाइमर है ना, तो ये ख़त्म होने तक पढ़ाई करूँगा और 10 मिनट का ब्रेक है हर 60 मिनट में। स्ट्रेंथ ऑफ मटेरियल, स्ट्रेंथ ऑफ मटेरियल।
State of stress means not stress is developed in two direction. Stress is developed in two perpendicular direction, means third direction is zero. Last one is biaxial state of strain is developed. In this case, which statements are correct now? A bar is subject to axial load first. So the longitudinal strain is going to be determined. So this is equal to what now? Delta d by d. Delta d by d. Now this is known or unknown. This is unknown. Strength is a theoretical subject or experimental subject. Strength is a theoretical subject. How do you know that d is delta d? Delta d is written as what now? But d1 is known or unknown? D1 is unknown. How to find out this D1? By conducting an experiment, tension test. But it is not a tension test. Transformative subject is a theoretical subject. Theoretical subject. Theoretically, we don't know. Assume initial diameter is 50. Final diameter is what? Less than 50. But we don't know is 45, 46. So D1 is unknown. So when the D1 is unknown, this one is unknown now. Strain is unknown. Change in diameter is unknown. When the change in diameter is unknown, lateral strain is unknown. So theoretically, which one can be determined now? Theoretically, what now? Stress is determined or strain is determined. We know the load and we know the diameter. We can find out the theoretical stress now. Theoretically, transformative subject is a theoretical subject. Theoretically, stress is determined. Strain is cannot be determined. Similarly, here also what now? What the actual equation for the longer strain? Change in length upon virginal length. Length will increase, but we don't know final length. How do you know final length? By conducting a tension test. L1 and D1 are known by conducting a tension test. Experimental is known. So when the L1 is unknown, delta L is unknown. When delta L is unknown, longer strain unknown. But how we are finding out the longer strain? By using the Young's modulus. Suppose if you don't know the Young's modulus, we cannot find out the change in length now. So the longer strain is going to be determined by what now? Young's modulus. Similarly, here what this lateral strain is unknown because D1 is unknown. When the D1 is unknown, change in diameter is unknown. When the change in diameter is unknown, lateral strain is unknown. So what the actual longer strain? X direction. So this is the longer strain. But the normal strain in the direction of the load is the longer strain. What the longer strain? No. What the dimension is there? L, delta L by L. Now these are known or unknown? Unknown because L1 is unknown. But what is the other way you can find out the longer strain? By using Young's modulus. So always theoretically which one can be determined now? Theoretically stress can be determined. Strain cannot be determined. Strain is determined experimentally by using the strain gauges. So always transformative, what should be the first step now? First you have to find out the stress. Then shall I go for the first equation or second equation? First you are going to find out the stress. Then can you use this first equation or second equation? Second equation cannot be used now. Why? Because L1 is unknown. We can use this equation because P is known, sigma x is known, Young's modulus known. So what the next step now? Strain is determined. How to determine the strain now? By using elastic constant. So to determine the longer strain, which one is required now? Young's modulus is required. So Young's modulus is used to determine the longer strain. Once you know this value, once you know this longer strain, already know longer strain from here now. Then you can find out the delta L. So always theoretically, what the first step now? Stress. First step is stress. Then strain by using elastic constant. Then you are going to find out the deformation. Then you are going to find out the final dimension. So this is the first calculation. Then this is the second calculation. This is the third calculation. And from this one, we can find out the L1 is determined. So what is the aim of the transformative main board now? This is nothing but the first chapter now. First, you have to derive the equation for the stress. Next, you have to determine the strain by using elastic constant. Then you have to find out the delta L. If you know the delta L, then you can find out L1. Now this is which load you have taken, axial load you have taken. So chapter to chapter, what change you are going to get it now? total 10 chapters are there. In the 10 chapters, aim is same, but chapter to chapter loading condition will changes. Chapter to chapter loading conditions are changes. In the first chapter, you are having the load is acting along the longitude axis. In third chapter, load is acting perpendicular longitude axis. If the load is acting like this is the longitudinal axis, then this load is called as what now? Transverse shear load. Beams are always subjected to transverse shear load, SFD, BMD. So in all the chapter, aim is same. So if somebody asks, what is the aim of the strength-thermometer? This is a strength-thermometer subject, but what you are studying, what the answer now? The aim of the strength-thermometer subject is to derive the equation for stress, then strain, then deformation. But to find out the strain, what is required now? Elastic constants are required. E and V are required. If you don't know E, we cannot find out the longest strain. When you cannot find out the longest strain, we cannot find out the delta L. When delta L is unknown, L1 is unknown. Similarly here now, the lateral strain is unknown. Because of what the D1 is unknown. So what should be the first step now? This will be a fourth step now. What the other way to find out the lateral strain? By using the Poisson's ratio. So this is the third step. Already you have calculated the longest strain here now. And if I know the Poisson's ratio, then you can find out the lateral strain. Why you use the minus sign now? Poisson's ratio is a positive. This longest strain is a positive. Length is increasing or decreasing, or length is increasing, but diameter is decreasing. This is a positive, this is a negative. And this, what is overall now? Negative. Negative and negative will become a positive. So generally default the Poisson's ratio is a positive. L1 is greater than L. L1 is greater than L means is a positive. But D1 is less than D, is a negative. So always longitudinal strain and lateral strains are unlike in nature. Longitudinal strain and lateral strains are unlike in nature. So we know the Poisson. Therefore, to determine the lateral strain, what is required now? You need the longitudinal strain and Poisson's ratio. Already you have calculated the longitudinal strain by using Young's model. Then additionally, what is required now? Poisson's ratio is required. So this is the third step. From this one, what will find out now? Longitudinal strain is known. Poisson's ratio, input data, then you can find out the lateral strain. So once you know the lateral strain, then you can find out delta D. If you know the delta D, you can find out the D1. So what's the first step now? Here, how many steps are in this question is given? What's the first step? Axial stress P by A. What's the next step now? Longitudinal strain. To determine the longitudinal strain, what is required now? E. Already know sigma x here now. Then E is required. This is the second step. I will call this as the first step. This is the second step. So from this one, what you can determine it now? The third step. From this one, what you can find out now? Delta L and L1. Delta L and L1. You know the longitudinal strain. Then you can find out delta L. If you know the delta L, you can find out the delta L1. And this is the fourth step. This is the fourth step. So your which data is required now? Poisson's ratio. You know the longitudinal strain. Then from this one, you can find out lateral strain is determined. Lateral strain. And this is the fifth step. And from this fifth step, what you are going to determine the delta D and D1. From this one, we are going to find out delta D. So this is the aim of the strength-thermometer subject. Strength-thermometer is a theoretical subject, it's not an experimental subject. In strength-thermometer, we are not going to study any experiment. All the experiments are studied in the material science. So strength-thermometer is a theoretical subject. And what you are studying for now? Aim of the strength-thermometer is to derive the expression for the stress, strain, then deformation and change in dimension. Deformation, then final dimension. Then what is the input data required here now? To do all this calculation, what is the input data? Load the input data. If you want to do this one, what is the data required now? Load the input data. Dimensions are required. Marginal diameter, marginal length is required. Additionally, what is the data required? E and U. So always there must come problem, what is the input data? Load, dimension, the initial dimension, initial diameter, initial length. Then additionally, what is required now? E and U. E the Young's model and U the Poisson's ratio. So always the input data for strength-thermometer, load the input data, dimension the input data, Young's model and Poisson's ratio is the input data. Somebody by the minus sign for Poisson's ratio positive. Always longitudinal strain, lateral strains are unlike in nature. One is a positive, one is a negative. If you apply a compressive load, what happens now? Length will decrease, diameter will increase. So the longitudinal strain, the compressive lateral strain will be a positive.
Exactly. That's what I understood.
Now this is called what? Triaxial state of strain. Triaxial state of strain. Why you are getting a triaxial state of strain? Because Poisson's ratio is not zero. By chance Poisson's ratio 0, no. Lateral strain 0. Lateral strain 0. Then epsilon by epsilon z 0. Then you are getting only longitudinal strain.
here since mu not equal to 0, therefore we got
Why this ratio can be not
epsilon x, epsilon y and epsilon z. That is,
and what about this now? In this case, what now? Length will increase, diameter will decrease, position. Same thing, but here what there is no change in dimension. In this case, only position change, dimensions are changed, but your dimensions are changed. But in this case, dimension will change and position also changes. So this will undergo both deformation and displacement. This will undergo both deformation and displacement. So I don't have the space here.
developed. If mu equals to 0, then epsilon y equal to epsilon z equal to 0. Therefore, you
Because there is no space and drawing this figure here. So what change you have to make it now? Length will increase, but the initial length L. But here what the length increases, diameter increases, but position is also going to change now.
भाई 8:50 हो गए. Only 40 minutes are remaining. फिर खाना खाने जाने का है.
So first and diamond condition, second one is that equilibrium. So what is the solution now? In a deformable member, in the direction of the load, both stress and strain are developed, and the relation between the equilibrium and law. And if you apply shear load, you are getting a shear stress and shear strain. Then the proportionality constant is what now? If the shear stress and shear strain sigma is proportional, then you are going to get a G. Now, anybody, what is the necessity of Young's modulus? Why you need the Young's modulus? Young's modulus you use to determine the longitudinal strain under uniactive state of stress. So, what is the exact definition of Young's modulus now? Young's modulus is the ratio of normal stress to longitudinal strain under uniactive state of stress. Your stress is developed in omnidirectional of one direction. So, Young's modulus is the ratio of normal stress and longitudinal strain under uniactive state of stress. And what the Poisson's ratio definition now? Poisson's ratio is the ratio of lateral strain to longitudinal strain under uniactive state of stress. And finally, what Young's modulus is used to determine the longitudinal strain under uniactive state of stress. And Poisson's ratio is to determine the lateral strain. Similarly, what G is used to determine the shear strain. G is the shear modulus. So somebody asked, why you need the elastic constant? Young's modulus is used to determine the longitudinal strain under uniactive state of stress. Poisson's ratio is used to determine the lateral strain under uniactive state of stress. And G is used to, G is what? Shear modulus. Shear modulus is used to determine the shear strain. And K is used to what? Determine volumetric strain. K is what a bulk model used to determine the volumetric strain under hydrostatic state of stress condition. What is the meaning of hydrostatic now? When sigma and sigma by sigma z are equal. When sigma and sigma by sigma z are equal and like in nature, it is the hydrostatic. If sigma and sigma by sigma z are equal in the triaxial or biaxial. So we is going to mention bulk model used to determine volumetric strain. In this case, bulk model is not valid now. In the uniaxial state of stress, the biaxial state of stress, uniaxial. Here, bulk model definition is not valid. Bulk model is valid under hydrostatic state of stress condition. Hydrostatic means it is a triaxial state of stress condition. Triaxial means how many stress are there in a tree? When sigma x sigma by sigma z, that is when normal stress in three mutual perpendicular direction. When normal stress in three mutual perpendicular direction are equal and like in nature. Equal like in nature. Like in means what? All are going to be tensile, otherwise all are compressive. So somebody will ask, what is the necessity of elastic constant? Why you need the elastic constants are required? Why E, G, K, mu are required? What the answer now? Theoretically, stress is determined. Strain cannot be determined. Strain is determined experimentally. But strength-o-meter subject is a theoretical subject. Theoretically, stress is determined. Strain cannot be determined. So to determine the strain theoretically, we need the elastic constant. Why you need the four elastic constants? Young's modulus is to determine the longitudinal strain under uniaxial state of stress. Poisson's ratio is to determine the lateral strain under uniaxial state of stress. Then G, shear modulus is used to determine the shear strain. Shear strain under pure shear state of stress, that is the biaxial. Pure shear state of stress, that is under biaxial state of stress. And bulk modulus used to determine the volumetric strain under hydrostatic state of stress. Hydrostatic means it will be a triaxial state of stress. Hydrostatic means what you mentioned, triaxial. That is what when sigma x, sigma y, sigma z are going to be equal and like in nature.
भाई सर खतरनाक पड़ा था, लेकिन श्री वो थोड़ा ओल्ड हुआ है ना, इसलिए थोड़ा सा स्लो हो गया। व्हेन बहुत स्लो लिखता हो वो 1.5x स्पीड पे इतना स्लो लिख रहा है वो।
Transfector. The first chapter, but if the load is acting perpendicular along with axis, that is called what now? Transverse shear load. Beams are always subjected to transverse shear load. That is SFD BMD chapter now. When a bar is subjected to axial load, that is AL. That is what a load is acting along the longitudinal axis. LA the longitudinal axis. What the longitudinal axis you studied now? Imaginary line joining the centroid. In a bar, how many cross sections are there? Infinite. If we join the centroids of every cross section, you are going to get a longitudinal axis. So what the conclusion here is now? When a bar is subject to axial load. Uniaxial state of stress, that is developed most of them are going to mention only one direction. That is incorrect now. Stress are developed only in one perpendicular direction. Means other two perpendicular direction is zero. Biaxial means what stress are developing two perpendicular direction, means third direction zero. Your syllabus restricted up to biaxial. Triaxial means stress are developing three perpendicular direction. And uniaxial state of stress. But uniaxial state of strain. When you are getting a uniaxial state of strain, that is when Poisson's ratio 0, that is the correct example, or triaxial state of strain is developed. That is when mu is non-zero.
क्या लाइन मार रहा है इतना सारा फालतू।
Sir, slide the slide. Which slide now? Previous one or this one? Now write down the aim of the strength of material.
When bar is subjected to axial load,
Aim of strength of material subject. Aim of strength of material subject is to derive.
that is load acting along the longitudinal axis.
Expression for stress and the deformation.
Uniaxial state of stress.
So when a bar is subject to axial load, what is the change in length equation? PL by AE, stress, strain and deformation under different loading conditions. Chapter to chapter what happens now? Aim will not change, only loading condition will change under different loading conditions. Under different loading conditions.
That is,
under different loading conditions.
Stresses are developed only in one perpendicular direction.
By using
but either uniaxial state of stress,
elastic property, or what is the name?
axial
Constant,
or
elastic constant.
triaxial.
That is Young's modulus and Poisson's ratio. How many elastic constant of 4? But we need E and mu. If you know the E and mu, the remaining two, what the remaining two now? A and G. Total elastic constants are 4 now. For a homogeneous isotopic material, number of elastic constants are 4. So if I know E and mu, the remaining two, to determine the shear strain, what is required? The G is required. But input that as E and mu. If you know E and mu, then G is going to be calculated by using relationship between elastic constant. That is E is equal to 2G into 1 plus mu. Similarly, if I know the E and mu, we can calculate the K. E is equal to what? 3K into 1 minus 2 mu. 3K into 1 minus 2 mu.
Aim of SOM subject.
And what the input data for transformative question?
Is to derive expressions for
What the input data?
stress,
Load,
strain,
dimensions.
and
When the
deformation.
dimensions are given, means the member is already manufactured. Now this is what this dimensions are known for. This is already manufactured. Then E and
Loading.
E and so what the calculation now?
Condition by using experimentally
First we go to develop on the cross section. What the meaning? What the definition of a cross section? What the definition of a cross section? Perpendicular longitudinal axis. Simple example is what if you consider bread packet. Bread packet is a solid, and bread slice is a cross section. How many cross sections are there? Infinite, based upon the length of the member. In bread packet, how many bread slices are going to be there now? Bread packet, how many bread slices are going to be there now? Depending upon the bread packet size, different type of bread packets are there now. So each bread slice is a cross section. Now what is the shape of the bread slice? Now rectangle. For rectangle, centroid will be exactly the mid depth. X bar is what now? P by 2, Y bar is D by 2. So if we join all the centroids of bread slices, we are going to get a longitudinal axis. Remember about a bread packet is a solid. But bread slice is about a cross section. Bread slice is a cross section. That is a 2D figure. Bread slice what now? Width and thickness is going to be there now. So bread slice is a 2D figure. But bread packet is going to have the 3D. Solid means 3 dimensions. Cross section means 2D. What are the names on a plane? Plane is a 2D figure. So cross section is a plane. It will have the 2 dimensions. So how many number of cross sections are there? Infinite. Now first step is what you have to do. Now locate the centroid of the cross section. Then join all the centroids. You are going to get a longitudinal axis. Longitudinal axis for a member. How many longitudinal axis will be there? 1. How many centroids are there? Infinite. Centroid is for a cross section. Center of gravity for a member. So what should be the first step now? Determination now.
Steps.
Maximum stress. By using
Determination of max stress.
By using Strom equation.
Maximum
On a cross section, how many loads are possible? On a cross section, there are 4 loads are possible.
Developed
On a cross section, 4 loads are possible. What are they now? Real load. On a cross section, 4 loads are possible. Out of that 4 loads, 2 are normal load, 2 are shear load. On a cross section, 4 loads are possible. 2 normal load and 2 shear load. 2 normal load means 2 normal stress are going to be there, and 2 shear load means 2 shear stress are going to be there. So on the cross section, what the maximum stress are possible now? 4. 2 normal stress and 2 shear stress. 2 normal stress and 2 shear stress. What the normal load now? Axial load. Next, bending moment. And how many shear loads are there now? 2 shear loads. What are they now? Shear force and a twisting moment. Timing you have studied only axial load you have studied. What is shear force, bending moment, twisting moment you have studied now. So on a cross section, 4 loads are possible. Out of the 4 loads, 2 are normal load, 2 are shear load. 2 normal load means 2 normal stresses. 2 shear load means 2 shear stresses. Normal stress is represented by sigma, shear stress is represented by tau. And how many are, which one are the normal load? Axial load and bend moment is the normal load. So the stress due to axial load is the normal stress, stress due to bend moment is the normal stress. Stress due to bend moment is also normal stress. Then you are going to get a sigma A. Sigma means normal. A means normal stress due to axial load. Sigma B, bending stress. That is what now? Normal stress due to bending moment. Normal stress due to bending moment. Next, 2 shear stress. Tau. Tau D. Tau D means what now? Direct shear stress. That is due to shear force. Tau T. Tau T is the what now? Tau T is the what now? Torsional shear stress. Torsional. Tau means shear. T means due to twistment. Torsional shear stress. That is what this mean now? Axial load. Axial load is a normal load. Then you are getting a normal stress. Then why you are using A now? Because there are 2 normal loads are there. Bend moment is also normal load. Then you are getting 2 normal stress. So to differentiate the 2 normal stresses now, we are using the sigma A and sigma B. Is a normal stress due to axial load. So what does the name now? Axial stress. So what the axial stress? Always a normal stress. Axial stress due to axial load. C. This is only you have studied now. This is studied in which chapter now? What the aim now? Derive the equation for stress now. This is studied in the first chapter. Just now you have studied now. This is studied in the chapter number 5. Bending stress chapter. This is all you are going to study now. M is the bend moment, Z is the section modulus, NE is the newton lax. All these terms you are going to study now. But I mean directly I am writing now. P the axial load, A the area, M is the bend moment, Z is the section modulus, NE is the newton laxes, NE is the newton laxes. Then two shear stress are possible now. What are the name for the P by A and P by A represents what average stresses. When these two formulas are valid now. When these formulas are valid now. When the P by A equation is valid now. When stress is uniformly distributed. When stress is uniformly distributed. This is what now? Average normal stress. This is average shear stress. Direct shear stress. Means that is due to shear force. Here P the shear force and here P the normal load. Axial load. Here P the axial load. Axial load is the normal load. P the shear force. Then tau T. T by ZP. T the twisting moment. T the twisting moment. What the other name for a twisting moment? A torque. T the twisting moment or what the other name? A twisting moment. Z is the section modulus. P the polar section modulus. P the polar section modulus. So why you are getting the 4 stresses now? 4 loads are possible. How many normal stresses? 2 normal stress, 2 shear stress. 2 normal loads are there. What are 2 normal load here? A the P the axial load, M is the bend moment. Both are normal load. 2 shear load. P the shear force, P the twistment. Both are shear load. What is the meaning of normal load? Perpendicular to cross section. Normal. Shear load means parallel to the cross section. Now from this 4 equation, what you can conclude it now? From this 4 equation, what you can conclude it now? Whether stress depend upon the, these stress are depend upon the material or independent of the material. Independent of the material. This is studied in which chapter? The chapter number 6, torsion chapter. This is studied in the chapter number 5. All the equation you are going to derive it, but try to remember this now. Now from this 4 equation, what you can conclude it now? A and P by A represent what average stresses. When these 2 formulas are valid, how many shear loads are there now? 2 shear loads. What are they now? Shear axial load you have studied. What the shear force, bend moment, twistment you are going to study now. So on a cross section, 4 loads are possible. Out of the 4 loads, 2 are normal load, 2 are shear load. 2 normal load means 2 normal stresses. 2 shear load means 2 shear stresses. Normal stress is represented by sigma, shear stress is represented by tau. And how many are, which one are the normal load? Axial. Remember this now. Now from this 4 equation, what you can conclude it now? Numerator, what you are taking a corresponding load. This is due to axial load. So numerator I take a axial load. This is due to bend moment. Therefore numerator I take the corresponding load. Bend moment. This is about a direct shear stress. This is due to shear force. Numerator shear force. And this is due to twistment. Numerator twistment. So always the stress on the cross section. Stress on the cross section. The maximum stress on the cross section. How to write it now? Numerator I take a corresponding load. Axial stress means numerator axial load. Bending stress means bending moment to the numerator. Direct shear stress. B means direct shear stress. Or otherwise you can call the average shear stress. Numerator shear force. Torsional shear stress means numerator twistment at torque. But denominator, what you have to take now? Corresponding geometrical property. Corresponding geometrical property. Just I mentioned now, all the material properties are given. Geometrical properties have to be remembered. These two are depend upon what the area. But this is dependent upon what these two are dependent upon the section modulus. This is a section modulus about neutral axis. Section modulus about polar axis. Is it? Depend upon cross-sectional dimension. For the area, if you go for a circular cross-section, what the area? Pi d square by 4. For the section modulus now, pi d cube by 32, pi d cube by 16. So overall, what does this depend upon the material? Independent of the material. It is independent of the material. So stress on the cross-section is independent of the material. Independent of the material is directly proportional to corresponding load and inversely proportional to corresponding geometrical property. Axial stress and direct shear stress means you have to take the area, and maximum bending stress and torsional shear stress means denominator you have to take the geometrical property. Which geometrical property? Section modulus. Axial load, bending moment, shear force, displacement or a torque, axial stress, bending stress. These two can be directly added. Both are not.
This is axial stress. This is bending stress.
So these two can be added. These two can be added. If both are in the same direction, directly can add it. But in the opposite direction, you have to take the algebraic sum. If both are in the same direction, simply addition. But both are in opposite direction, sigma A minus sigma B max. So both are normal, so these two stresses can be added. Added means what? Algebraic sum you have to take it. Both are in the same direction, simply plus. Both are in opposite direction, minus you have to take it. So these two stresses can be added, these two stresses can be added now. But these two cannot be added, these two cannot be added. Stop. Numerate, what I have to take it now? Corresponding load. T by ZP. T that displacement. T that displacement. What does? For a displacement, a torque. P that displacement, or what are the name of displacement? Z is the section modulus. P the polar section modulus. P. Polar section modulus. So why you are getting the 4 stresses now? 4 loads are possible. How many normal stresses? 2 normal stress, 2 shear stress. 2 normal.
अबे उसका नाम क्या है वो तो बता ही नहीं रहे.
Axis, any other neutral axis. Then any other neutral axis, any other neutral axis. Then P by A and P by A represent what average stresses. What are the name for the P by A and P by A represent what average stresses? When these two formulas are valid now. When these formulas are valid now, when the P by A equation is valid now, when stress is uniformly distributed, this is what now? Average normal stress, this is average shear stress, direct shear stress, means that is due to shear force. Here P the shear force and here P the normal load, axial load. Here P the axial load is the normal load, P the shear force. Then tau T. P by ZP. T that displacement. What are the name for a displacement? A torque. T that displacement, or what are the name of displacement? Z is the section modulus. P the polar section modulus. So why you are getting the 4 stresses now? 4 loads are possible. How many normal stresses? 2 normal stress, 2 shear stress. 2 normal loads are there. What are the 2 normal load here? A the P the axial load. T by ZP. T that displacement. segment. What the other name for a segment? A task. P the segment, or what the other name? A segment. Z is the section model. P the polar section modular. P the polar section modular. So why you are getting the four stresses now? Four loads are possible. How many normal stresses? Two normal stresses. Numerator, what I have to take it now? Corresponding load. What is the meaning of corresponding load? Axial stress means numerator axial load. Bending stress means numerator bending moment. Direct shear stress means numerator shear force. Torsional shear stress means numerator twisting moment. And denominator, what should I take it now? How many loads are possible on the cross section now? Four loads are possible. What are they? Axial load, shear force, bending moment, and twisting moment now. Then denominator, what should I take it now? Corresponding.
Therefore, max stress on the cross section is corresponding load on the cross section upon corresponding geometrical property of the cross section या फिर of the material.
Axial load, denominator area. If a shear force, area. Bending stress means section modulus. Z means section modulus. NA is the neutral axis. Everything I'm not writing, but so many times I've repeated. Last class I mentioned now. पहली बार सुनो, दूसरी बार लिखो, तीसरी बार क्रॉस चेक करो. But 90% I'm writing on the board, but only 10% I'm leaving now. If offline batches, I will write down only 70% now. Because the students are in front of me now. Then I can directly whether they are writing, I can know it now. But you are sitting in different place, different city, and different part of the country. I'm taking this from Delhi center, so we don't have the direct interaction. So I don't know whether you are writing or not. That's why what now? I'm repeating what now? 3 times or sometimes more than 3 times I'm repeating now. That's why always the online classes will take them more time now. And from this, what the conclusion, what the important conclusion now? The maximum stress on the cross section, is independent of the material. That's why in the last class you have discussed one question now. When cast iron bar is pulled with a load P, one mild steel bar is pulled with a load P. Areas are same, but stress is same now. One mild steel bar, one MSQ question was discussed last class now. Have two identical bars, same diameter, same length, but one is a mild steel, one is a cast iron. Both are pulled with the same load now. So in both the bar, which one is same? Stress is same. Even though they are made of different material, but stress is same. But which one depend upon the material? Strain and deformation are depend upon the material. Change in PL by AE. So strain and deformation are depend upon the material, but stress is independent of the material. Under externally applied static forces. Externally applied static load. But this is depend upon the material. Strain and deformation are depend upon the material.
Under external applied static loads, external
by E is depend upon the material. Material to material changes. Longitudinal strain inversely proportional to Young's modulus. Shear strain depend upon the shear modulus.
Loads. Stress on the.
But when stress depend upon the material, clearly what I mentioned, externally applied static load. But four conditions, stress also depend upon the material. What are they now? Self-weight. Self-weight is not externally applied load. Impact load. But I mentioned static load. Stress depend upon the material. Three conditions. What are they now? Impact load. Next. Self-weight. Next. When thermal deformation is restricted. Under following conditions. For the following condition, the first condition is what now? Self-weight. But self-weight is not externally applied load. Next one is the impact load. But impact load is not a static load. And third one is what? When thermal deformation restricted. Thermal deformation not due to externally applied load. Thermal deformation is what now? Due to change in temperature. Each and every conclusion will be important. So many times probably I don't know whether I mentioned in the last class or not. If you have today's lecture, if I made some 20 conclusions, out of the 20 conclusions, 15 conclusions are already appeared as an objective question in some of the previous year question, maybe GATE or engineering service or civil services, ISRO or DRDO. But the remaining 5 conclusions, we don't know which year you are likely to get it. There is no unnecessary information in my class now. Each and every point is useful. I'm not going to waste your time. I'm wasting my personal time only. I'm not going to relax now. I'm not going to allow you to relax now. I want you to take a full time now. So this each and every, some students are good now. Today, when I'm discussing the morning batch now, they are not focused now. They want only problems. When I'm discussing the basics, they are not focused. Today I done a problem. Then everybody is getting a doubt now. Directly we cannot go to the problem now. First of all, your concepts should be clear now. So focus on the concept. Once the concepts are clear, then you can do all the questions. But they will not focus, they want only problems. Without knowing, it is not a university examination, completely GATE is a concept oriented. So each and everything is going to be important now. First one is what now? Self-weight, impact load, and then thermal deformation, based upon this conclusion, one of the GATE paper already question was there now. 2 questions are there. Based upon this, 2 conclusions are 2 questions are there. Directly you can answer it now. But some students have without this also done it now. But they wasted the time now. Getting the answer is not a criterion. Getting the correct answer within the less time. Some students are going to do the question, but they are wasting the time. But if you remember this conclusion, directly select the option now. If you want to get a success in the GATE examination, you should behave like a flywheel. A mechanical engineering student should get a success in the GATE examination, you should behave like a flywheel. You know already the flywheel function. Flywheel is what now? Wherever X energy store it, wherever deficient it release now. So wherever required, you have to cut down the time, and that time you have to release for the lengthy question. Some questions are going to take the 5 minutes time now. Some questions may take the 10 minutes time now. Then maybe you are going to get the extra time now. If you can cut down the time for some simple question, that is what, if you use the concept oriented, directly you can answer it now. Then what the next step now? This is completed. What the next step now? Strain. How to determine the strain now? By using elastic constant. Determination of strain by using corresponding elastic constant. E is the elastic constant. What is the elastic constant? E. K. E is used to determine what now? Longitudinal strain under uniaxial state of stress. This is used to determine the shear strain. This is used to determine the volumetric strain under hydrostatic state of stress. This is used to determine the lateral strain. Used to determine longitudinal strain under uniaxial state of stress. Uniaxial state of stress. That is important. That I not used to determine the longitudinal strain under uniaxial state of stress. This is used to determine shear strain. Shear strain is represented by gamma. Under pure shear state of stress. Under pure shear state of stress. For the pure shear state of stress, this is under uniaxial state of stress. That already you have studied now. This is under pure shear state of stress. For the pure shear state of stress, you are going to study separately. Pure shear state of the biaxial state of stress. Biaxial. This is used to determine volumetric strain under hydrostatic. No, the uniaxial, the biaxial, the hydrostatic. What the hydrostatic is studied now? When sigma x, sigma y, sigma z are going to be equal and like in nature. This is not valid under uniaxial. It used to determine the volumetric strain under hydrostatic state of stress condition. That is when normal stress in 3 directions are equal and like in nature. And this is used to determine lateral strain under uniaxial. Used to determine the, this is also uniaxial, this is also uniaxial. This is under hydrostatic. This is a pure shear state of stress, but pure shear state of stress will be a back-deal state of stress. Then third one is what now? Determination of deformation. Just I have given all the examples for the axial load. For the first step, axial load, sigma equal to P by A. Next, what you have said, a long strain. How you have calculated the long strain? Sigma by E. Then next, you have calculated the change in length. Then you have calculated the lateral strain. Then by using the lateral strain, you have calculated the change in diameter.
To determine longitudinal strain.
So this is today's lecture. I'm going to stop it here. To solve the problem, already what tomorrow we are going to discuss very important loading concept, building up and everything we are going to discuss. These are all not important now. So today's lecture I'm going to close it here, and tomorrow once again you are going to join it at 6 o'clock. You are going to join it. Please try to review the class notes. Each and every point important. I've already mentioned reviewing the class notes is not reviewing the newspaper. Try to understand each and every point. Try to understand each and every point. And already explained the assumptions I mentioned now. Conformity equation based upon 7 assumptions that are not written on the board, but 7 assumptions. What's the first assumption now? Perfect elastic body. Next one is what? Prismatic. Next one is what? Made of homogeneous isotropic. Self-weight is neglected. Static load. Static load. Member is under equilibrium condition. Next, stress and strain are within the elastic limit, within the elastic region. Perfect elastic body. Next, prismatic. Hydrostatic. For the hydrostatic you have studied now. The back-deal state of the back-deal. This is used to determine volumetric strain under hydrostatic now. The uniaxial, the back-deal, the hydrostatic. For the hydrostatic you have studied now. When sigma x, sigma y, sigma z are going to be equal and like in nature. This is not valid under uniaxial. It is used to determine the volumetric strain under hydrostatic state of the condition. That is when normal stress in 3 directions are equal and like in nature. And this is used to determine lateral strain under uniaxial. It is to determine the, this is also uniaxial, this is also uniaxial. This is under hydrostatic. This is a pure shear state of, but pure shear pure shear of the uniaxial state of stress, uniaxial state of the state of stress. This is used to determine shear strain. Shear strain is represented by gamma. Under pure shear state of stress, under pure shear state of stress. What the pure shear state of stress? This is under uniaxial state of that already I studied now. This is under pure shear state of stress. What the pure shear state of stress you are going to study separately. Pure shear state of the back-deal state of stress, back-deal. This is used to determine volumetric strain under hydrostatic now. The uniaxial, the back-deal, the hydrostatic. What the hydrostatic you have studied now. When sigma x, sigma y, sigma z are uniaxial. Used to determine the, this is also uniaxial, this is also uniaxial. This is under hydrostatic. This is a pure shear state of, but pure shear state of will be a back-deal state of stress. Then third one is what? Determination of deformation. Just like all the examples for the axial load. For the first step, axial load, sigma equal to P by A. Next, what you have said, a longer strain. Now you have calculated the longer strain, sigma by E. Then next, you have calculated the change in length. Then you have calculated the lateral strain. Then by using the lateral strain, you have calculated the change in diameter. Good. Very important. Loading concept, building up and everything we are going to discuss. These are all not important now. So today's lecture, I'm going to close it here. And tomorrow, once again, you are going to join it at 6 o'clock. You are going to join it. Please try to review the class notes. Each and every point important. I've already mentioned reviewing the class notes is not reviewing the newspaper. Try to understand each and every point. Try to understand each and every point. So today's lecture completed. We'll continue tomorrow. So if you have any queries, you can send it. Otherwise, I will close the session. We'll continue tomorrow. Otherwise, it is not possible. Exactly 10 o'clock, it is not possible to stop it now. Otherwise, I have to stop at 9:30 or 9:45. Then it will take more time. Already, I'm taking 50 hours more than the allotted now. Then otherwise, if I take the every day, only 3.5 hours now. Every day, if I take the 3.5 hours, it will take almost 2 months time. Will take it now. Because you have to complete the other subjects also. It is not only for 12 subjects. So many other subjects are there now. Your syllabus will be completed on time, and you should get a sufficient time for practice, appear for the test series, etc. So that's why I want to utilize the more time now. Definitely during my classes, 6 to 10. 6 to 10. I have also not taken any break now. 6 to 10. Definitely the classes will be extended by 10 minutes, not 1:30 in between. in between the topic exactly 10 o'clock, I cannot stop it now. Otherwise, I have to stop it 15 minutes before now. Then it's a waste of time now. Then it will take more time now. So this is one slide. If you don't have any queries, you can log off your system and then join tomorrow by reading the class notes now. This is one slide.
चलो भाई, एक और लेक्चर कंप्लीट हो गया, नंबर 2। अभी मैसेज चेक कर लेता हूँ कोई आया या नहीं। कौन है भाई? अरे मोहिनी, हेलो। कोई देख रहा है तो हेलो बोल दो। अरे अथर्वा, अभी रोहित चांडक, अरे भाई रोहित चांडक, भाई मेरे कितने साल पुराने दोस्त है, बाप रे, 6 साल पहले, 6 साल पुराने। हे तो आज तो सिंह चड्डा, हेलो हेलो, हाय चड्डा जी। तो आज आप बिना चैट्स पढ़े पढ़ाई करने वाले हैं? हाँ, 10 मिनट का ब्रेक है। माय ब्रदर बबलू चड्डा, सही है। सब्सक्राइब कर दो यार। अगर अभी ख़त्म ही होने वाला है, अभी 9:30 बज गए हैं। मैं खाना खाने जाने वाला हूँ अभी। मतलब ख़त्म ही हो गया, मेरा लेक्चर भी ख़त्म हो गया, तो अभी खाना खाने जा रहा मैं। यूपीएससी छोड़ो और तोप में ध्यान दो। तोप तोप है कि टॉप, क्या बोल रहे, क्या मालूम। तोप तोप, मेरी तोप कितनी बड़ी है पता है आपको? अबे चूतिए, तेरी माँ का साले, तेरे को ब्लॉक कर रहा मैं। अरे प्रथमेश भाऊ, हेलो। नहीं ना, अभी खाना खाने जा रहा मैं। 7 बजे से पढ़ाई कर रहा था। चलो टाइम हो गया। मैं आता 10:15 बजे, फिर से चालू करता स्ट्रीम, तो मिलते हैं। हाँ चलो, बाय, थैंक यू फॉर ज्वाइनिंग, बाय बाय। 10:15 को मिलते हैं अभी।